In this example, so looking at probability and statistics, they did a survey of 2,000 people in St. James. And 1,400 people said they either use glasses or contact lenses to help them with their vision. Based on that data, we have to predict how many people in Winnipeg, and assuming Winnipeg has a population of 633,000 people, need glasses or contact lenses. And then we'll talk about whether or not we think this is reasonable. So this is how statistics is used. It's often not easy to ask everybody in an area. It would take a long time to ask everybody in Winnipeg. So instead, they do a survey of less people. They did a survey of 2,000 and 1,400 had glasses. So the first thing that's happening here, to start off, is we're first finding the percentage of people from the survey that wear glasses. How do you find a percentage? How do I find 1,400 out of 2,000? How do I use my calculator to find a percentage? What would you do if you had a test and you got 1,400 out of 2,000 on the test? Yes? Yes, you just take the two and divide them. You get a decimal, which is 0.7. You can change that decimal back to a percentage. That was something we did in our first unit. So 0.7, that's 70%. Once you figure out the percentage from the survey, if the survey is a valid survey, you should have that same percentage in all of Winnipeg. So then your next part that you're saying is that in Winnipeg, that would mean 70% of the whole population of Winnipeg should have either glasses or contact lenses. How do you do the math here? Do you remember how we've done percentages of before? What do you type into your calculator? Well, 70% in your calculator, you type in 0.7. The of is multiplying, and then you get your answer. Oh, and then you times it by 100 to change it to percentage. Yeah. What do you think? Is this reasonable? Yeah. How many people wear glasses or contact lenses in this class? Are we at 70%? 1, 2, 3, 4, 5, 6, 7. 7 out of 2, 4, 6, 8, 10. Or 8 out of 12? So we're at 8 out of 12. That means our percentage in our class is 67%. So 70% may seem reasonable. To me, it seems higher than I would think. Yeah. So, and it's kind of hard. You probably don't think it's as high a percentage as this, because there are people that wear contact lenses, and you might assume, oh, they don't wear glasses, because you can't notice it, right? Okay. Actual statistic from Statistics Canada is that 61% of people need glasses. So that's just interesting. Here's our next survey. Survey was conducted in downtown Winnipeg, and 30 out of 100 people said that they smoked. Could this data be used to predict how many people in Canada smoke?
Yes.
It could be. You could use it to predict, right? But would it be biased? Would it be maybe?
Well,
You might think maybe more people downtown smoke than other areas. Perhaps. I'm not sure. The sample is also pretty small, only looking at 100 people. The smaller your sample is, the less likely it is to show a bigger picture. A bigger sample that you do could be better. So we have some issues in here. We talked about the sample size being small. That might throw things off for predictions. Have you heard of this word before? Demographics. What does it mean? No idea. Demographics is a fancy word for the characteristics of a population. So does the characteristics of the population of downtown Winnipeg represent Canada? That would be another question you would ask. So you're saying downtown Winnipeg is scary, so it wouldn't be the same as surveying people in this area? Maybe, maybe not. It might not be a true representation. Just like if you decided you were going to take 100 people in Steinbach as your survey. Right? We have ideas that populations are different. Do you think you would find more people smoking in downtown Winnipeg or in downtown Steinbach?
Downtown Winnipeg.
So you have assumptions about the population. We're not sure if they're right or not, but we have to realize that when we do have assumptions, those do bias us. Interesting. Actual statistic in 2012, 20.3% of Canadians smoked. While in Manitoba, only 20.1% of Manitobans smoked in 2012. What do you think is the trend right now? Do you think that number is the same, or do you think that number is going down? I would think, I would hope it's going down as well. I think vaping is going up, so it depends if they include smoking with this. Maybe. Right? One of the reasons that smoking is going down is we're finding out more and more of the health things that are caused with smoking. So now people are making a decision, maybe I'll stop smoking because, or maybe I won't start because of the health reasons. Okay? Be crazy if all of a sudden they found out drinking water causes something bad. I don't think that'll ever happen. But at one time, smoking was assumed to just be fine. I mean, it wasn't bad for you.
Those commercials were like
Promoted kids to do it. So crazy.
Companies tried to do that so that they would get more customers.
Okay, multiple choice question. The last 3 days, Alexa had a test and ate an energy bar on her way to school that morning. She did well on the test. Today she had a test, so she ate an energy bar on her way to school. Was her decision based on theoretical probability or experimental probability? Or a subjective judgment? So theoretical is saying that something always happens, like flipping a coin is 50-50. Okay? Experimental probability is when you do an experiment, look at the results, and then use those results to tell yourself what to do next. Here's a bad example of an experimental probability. I take a coin, I flip it. I got tails. I got tails. That means next time I flip it, I'm going to get tails again. Is that a good? No. Right? Just because I have one experiment that says I got tails doesn't mean everything after that's going to be tails. Unless we're working with Duncan's coin that he glued together. Okay? So, in this case, wow, the computer is really slow. She used an experiment and was basing her next result on that experiment to decide. John's co-workers pool their money so they can buy lottery tickets and increase their chance of winning. Is their decision based on theoretical probability, experimental probability, or a subjective judgment?
What's subjective?
Subjective judgment is just what you're thinking on your own. In this situation, this is theoretical probability. More tickets have a better chance of winning as compared to one ticket. Does that make sense? If you do a draw out of a hat and you have 1 out of the 100 tickets, what are your chances of winning? 1 out of 100. But if you have 99 out of the 100, right, you're probably going to win.
Unless that one person is very, 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 very lucky and that one person.
Haley will not go on a cruise because the boat may sink, even though cruise ships are very rarely involved in accidents. Is her decision based on theoretical probability, experimental probability, or subjective judgment? That one's just based on her thoughts, which is subjective judgment.
It is judgment because what if they have a very good boat?
Yeah, they could have a very good boat.
She's just making an assumption down below.
Okay. There is your homework, which I'm going to get you to work on for the rest of the class. If you do not have it, there's page 419. And you can study from this. I'll keep this up.